Welcome to Portfolio Planning Plus, which is the web platform for portfolio modeling in the energy and chemicals industry, as our LinkedIn page says. So first thing first, if you are not doing it, just click the follow button on our page. This will give you access to latest news, information and updates on everything we are doing on Portfolio Planning Plus. Then you can access the website by clicking the visit website button, or you can follow the link to the homepage, to the landing page, which is portfolio-ppLUS.com. This is what I am clicking now, and then you are landing on our home page, which shows that ppPLUS is a data platform to model the energy and chemicals industry asset by asset. We have 4 modules on the landing page about companies and sites, about mass balances, about technology, about products. And in this video, what we want to do is explaining how we are sourcing and collating the information and the data we use on the platform. And for that, we take an example. We want to illustrate where we get information for the Dow polyethylene solution process, which is used on the Sadara petrochemical production site in Saudi Arabia. So we search Sadara in the entities and sites, and we find this description about Sadara entity and the corresponding site. When we click on the entity, then we land on the entity description for Sadara with all the details, and we have a communicator where we are posting information about, for example, sources of information like the Sadara corporate awareness presentation with a description, and then we can click on the link to the document, and here we see this document, which is available on the internet as a PDF. But to better navigate, we already downloaded this document, and we can search for the information which are relevant for us. Of course, there is a wealth of information that presentation has been used for modeling the complete Sadara site, but more specifically, when we look at the LLDPE, so the linear low density polyethylene products that the Dow P solution process in Sadara is making, we first look at information about the products, and in the product section, when you click on that, we find a linear low density polyethylene. Then again, we can click on this, and the information we obtained from there is that there is a 750 kTA, so kiloton annually of LLDPE for Sadara solution PE process. Now we want to have more details about these products and these production plants. We go to the process section, and we see here in this part that the plastics which are made are polyethylene made on 3 trains, and high pressure LDPE, which is a different product than the linear low density polyethylene. What we're interested into is this here. So we click on there, and maybe if I increase the size here, we can see it better. That Dow uses its proprietary solution process to make polyethylene with a capacity of a 750 kiloton in 2 trains. We'll explain what it does. And there is an additional train for that has a lower capacity to make elastomer materials. Actually, the polyethylene which are made with these 3 trains are using different type of comonomers, like 1-butene, 1-hexene, and 1-octene. So we already have a number of information which are very helpful for us to understand what is done in Sadara. And now we want to look at the technology, and for that we go to the technology section on the website, and we're searching for the Dow PE solution process. We can search in that field on the top left, or we browse through the pages by clicking on page 2, and we find here Dow loop solution PE process. So why Dow loop? It's because we have collected information from the internet, and we have a first description of the solution PE process. Here we have pulled from a patent that is linked here below the description, and when we click on that, we land on the, for example, the Google patents page that describe the olefin solution polymerization process assigned to Dow Chemical Company, and it has a lot of information, details about the process. For example, the type of reactor which is used, which is a loop reactor with 2 different heat exchanger. In a different version of the process, there can be 2 loops in series where 2 different molecular composition can be polymerized in series. In the first reactor, or first composition that is transferred to the second reactor, where different composition is polymerized. And for the man of the art, it's very clearly understood what these loop reactors these reactors in series make. They are making biomodal products, and we'll see why this is relevant for the description and for the modeling of the assets in Sadara, for the PE solution assets in Sadara. We have a second description, a second information here, which is a schematics, a block flow diagram of the process. We have another link, and when we click on that to find the source of this information, actually it's a presentation made by Dow in 2015, and here we can see that we have, for example, the block flow diagram for the full process, or we have the reactor, the loop reactor description with its different components and characteristics. So let's go back to the process description. We are creating units, so we call them units, which are the individual, so you can see here the list of units, which are the individual devices in a so-called technology. And for each of these units, we give a description. We can either click here, or we can click on the list of the technology units. And if there is, for example, an image, a description, schematics, it appears here, like for the loop reactor, which is a flow loop reactor, and a description again that we have pulled from the Google patent, from the patent of Dow Chemicals Company about this process. Now if we go back to the solution process, so the technology description, in the bottom we have the technology licenses, or actually where the technology is in use, and for the time being we have it in use only at Sadara, or there are many more production plants worldwide which are using this technology, but we have not yet modeled them. We have only modeled Sadara, and we see the 3 trains which are in use at Sadara. Let's click on the first train, and here we have a description of LLDP train 1 at Sadara, and what we say here is that it is manufacturing C4. So C4 is the acronym for 1-butene, because it has 4 carbon as a comonomer, so it makes a C4 LLDP copolymer with a specific density range according to Sadara project information. How do we come to that? Practically, we can look at the portfolio of products of Sadara, which is here. They make 3 different types of product of LD products. They are the C4, polyethylene, Diolex, and Elite. C4, as the name implies, C4 stands for C, and 4, which is 1-butene. If you click on this section and you look at one data sheet, then you will have a description that the C4 is made from 1-butene. So it's a 1-butene copolymer LLDPE product. We go back to the portfolio of products, and then we have two other products which are Dowlex and Elite. So we try to understand what these products are and where they are made. So we have said C4 is made in the LDP train 1. From market information, it is very well known to the man of the art that C4 LDP is the dominating LDP product in the market with the highest market share, and it's a commodity type of product because it's cheaper to produce because of the lower cost of the C4 comonomer and the lower concentration of conomer that is required to make this type of LDP product. Therefore, we assume that one of the two trains, which have equivalent production capacity, is fully utilized to make C4 as in a single loop reactor configuration. If we click here on the loop reactor, we have assigned a quantity of 1 to this unit. So one single loop reactor is used to make the C4 copolymers. So we can go back and now look at the assets and search for the second LLDPE asset, which is LDPE train 2, and here we make a different assumption that it is manufacturing C6 LDPE and C8 LLDPE with a specific density again corresponding to LLDPE. And why do we assume that these two type of copolymers are made on this asset? It is very well known again to the man in the art that the Dowlex and Elite products, they are a different type of animal, and even if the data sheet don't reveal that information, we can go to former communication of Dow chemical company about Dowlex and Elite products, where they explain that either 1-hexene or 1-octene is used to make the LLDPE copolymers, such as octene-based or hexene-based LLDPE. And another information that this communication reveals is that the Dow solution process technology is used to make the Dow LDP resins by allowing greater molecular weight distribution. What this concretely means is that two reactors are used in series. It's this configuration to make bimodal products. Then in that case, when we model the process, we use two loop reactors to have a correct depiction of the configuration of these units. Now, also it is very well known that in the market, C6 LLDP product is more important in terms of market share than C8 LLDP. The next assumption we make is that since this asset is used to make these two family of LLDP products, they are made in quantities which is greater for the C6, 2/3, and smaller for the C8. We assume 1/3 of the capacity is reserved for the C8 LLDP. The next information we need is when we look at the mass balance, what type of what quantity of comonomers is required are required to make the copolymers. We need to look at the imports. So Sadara is importing a certain number of products such as feedstock, we can look at all the imports that the site needs to import or buy. We have the comonomers, and we have many chemicals that the site is not making itself. Also the feedstock, like the petroleum naphtha or the natural gas and so on. In terms of monomers, they don't make one butene or one hexene or one octene. They are imported, and we need to know the quantity actually which is imported. For example, for the 1-butene, the C4 copolymers, we say that 5 weight per cent of 1-butene is required to reach LLDP density of 918291 gram per liter. So once again, let's look at the portfolio of products for the C4. And this is the density range that is covered by the C4 polyethylene products. And then how do we assume that this is the quantity of conomer that is used? We have compiled the information details from the scientific literatures, from information available on internet, from company presentations on their portfolio of products, on the technologies and so on. And what we find is that, for example, for making this density range for the C4 LDP, we need around 5 weight percent of C4 comonomer. For making same density C6 copolymer, we need maybe 10% of 1-hexene, and for making around the same density with octene, we need 15% of 1-octene copolymer. And then we have two more type of products. We'll see that in a minute when we look at the POE POP asset train 4 for making the plastomers. Typically one octane is used as a comonomer, and for reaching the plastomer density range, we need around 20% of octene, 1-octane as a comonomer. And for making the plastomers, since 1-octane is much too expensive for that purpose, then 1-butene is used. Then to reach the elastomer density of around 870, then about 50% 1-butene is required. So let's go back to our to the sites, and we will go back to the imports. And for the 1-octane 1-hexene, for example, which is used for making the C6 LDP in train 2, we have the information that 10 weight percent of 1-hexene is required to reach LDP density of 0.91620 0.920 gram per liter. Finally, this brings us to the production, and we are interested to look at LLDP production. For example, LLDP train 1 is making exclusively 3.75 kilotons. We assume that the two trains, they have the same production capacity, and train 2 has a split of 250,000 tons of C6 LDP and 125,000 tons annually of C8 LDP, based on the assumption that if I increase that, it will be better visible, readable, that C6 and C8 LDP are produced in a ratio of 2/3 and 1/3 respectively. We go back to the production numbers, and then we look for POP or POE, which is practically the same, which is actually the same train. And then we can look at the production here. We make equivalent quantity 50% of elastomer and 50% of a plastomer product in this train. Then we have the final mass balance for the complete site. We see here If we look, maybe it's better visible if we look at the chart. Then we have all the imports, petroleum, naphtha, ethane to feed the cracker, and the monomers, for example, to feed the polymerization plant, the three trains making LLDP and the POP, and all the over imports. That means not everything that is not made or consumed within the site. And then we have the output, which are all the products which are either commercial or which are not completely used within the site by the various assets, or which are, for example, waste streams like from the different production units, wastewater, spent acid, and other waste streams. And we have also, for example, fuel gas and so on. So this is all the products, and we see, of course, the LD products and POE and POP plastomers. Okay, one next step of development for the platform is that we intend to implement a visualization of block flow diagrams to have a complete depiction of complete site with the block flow and the stream product streams through all the assets and between the units as well. So this is a summary that explains how we are doing the modeling of assets and sites on Portfolio Planning Plus. Practically, we like to have you joining us for collating information, because how the platform is working, it's a collaborative tool, an open access platform which is collating data from the community of experts and specialists globally. If you join us, then you will be granted access as a member that can be elevated to a collaborator, data collator status, to help us modeling assets and sites by adding information that we may not have immediately available. For example, if we speak about the DAO PE solution process, we have not information available about, for example, the catalyst or the waste streams that are produced in the asset. The yield is not 100%. We have not captured this. Maybe there is 1, 2, 3% of waste streams which are produced from the asset. And also we are not taken into consideration, for example, the use of the solvent that goes into the asset. Of course, the solvent is recycled, but there are some part of it which is lost in every run. So this is the type of information that anyone contributing to the site of the platform can help add to the database to improve the quality and the precision of the modeling we are doing on the platform. So we are really looking forward to welcome you as members and contributors on the platform, and thank you very much for your attention.